Starting the class, children. So in the last class, we were talking about cell potentials, galvanic cell, heating and cooling curves. We discussed all these topics, bond enthalpies, heating, cooling, thermal equilibrium, heat capacities. So these were the topics which we did in the last class. Today, the aim is galvanic cell also we did, cell potential also we did. Today, aim is to finish this remaining part of Unit 9 and start with Unit 5. Okay, so let's start with this cell potential under non-standard conditions. So you already know how to calculate cell potential under standard condition. You know the meaning of standard conditions. Under standard condition, you are going to call it as E-node cell. E-node cell, right? Under standard conditions. Okay. And E-node cell you're calculating by using E-node cathode minus E-node anode. If reduction potentials are given. Arana, what's the question? Yes, we are still on that. We are finishing it today. Okay. So E-node cell is E-node cathode minus E-node anode. This is one equation. Then another equation which we did, E-node cell is minus NF E-node cell. No, I'm writing it wrong. We did another equation that delta G naught is minus N F E naught cell. If I know delta G naught, I can calculate E naught cell. Then another equation which we did was E naught cell is minus E naught cell is not minus, just plus 0.0591 over N log K. All the three equations will be given to you in the examination. Now, depending in the question, what information is given to us, we'll use these equations. If reduction potentials are given, you can use this one. If delta G naught and the balanced equation is given, then you can use this equation, this one. And if equilibrium constant is given, then you can use this equation. So that's the calculation of cell potential under standard condition, right? Okay, so I'm going to erase this. Now today we are going to learn, we are going to review about how to calculate standard potentials under non-standard conditions. Under non-standard condition, we are going to call it as E cell. Call it as E cell. And E cell is E naught cell minus 0.0591 over N log Q. This equation, we did the derivation. AP is not asking the derivation of this equation, but I think I explained to the derivation. So this is delta G naught equation. This is Nernst equation. We call it as Nernst equation. Now in the AP exam, you're going to calculate E cell for non-standard condition by using this equation. But they say that there will be no question in which they will ask you to do calculation. Calculations will not be needed. Okay. So we are going to do predict the sign of E cell, compare E cell with E naught cell. So you will have questions like this: E cell greater than E naught cell, E cell equal to E node cell, E cell is less than E node cell. So these questions will be there. Predict. And how to predict? This can be done with the help of log Q. But what is log Q? Q is just your reaction quotient under non-equilibrium state. Here it is non-equilibrium state, right? So Q is non-equilibrium state. It has the same expression as K. So if I write down an equation like this, A solid reacting with B2 plus aqueous, giving you B solid A2 plus aqueous. So can you tell me what is the Q expression here, children? Q expression? It is the same as K. Expression will be the same. Only thing is that when Q becomes equal to K, the equilibrium constant, then there is equilibrium. But if Q is not equal to K, then system is struggling to get the equilibrium. So what is Q expression for this reaction? Equation you can see is already balanced. It is the concentration of A2 plus over the concentration of B2 plus. Yes, good. This is Q. Now this is for you, children. Okay, the question is for you. I'm not going to help you, Arya. So can you tell me if Q is greater than 1, what will be the value of log Q? This log Q. I'm going to use slightly thick pen because I think this is not visible to us. So if I use the thick pen, you can see it well. Q is greater than 1, log Q will be positive. If this condition is there, if Q is big, what is more? The products are more or the reactants are more? If Q is big, what is more? A2 plus or B2 plus? Yes, Sushant, what is more? The products are more. If products are more, in that situation, in which direction the equilibrium will shift? This is a non-equilibrium state, right? Q wants to become K. And you're saying Q has more products, so it will shift to the left. If it is shifting to the left, is it giving you more electricity or less electricity? Because reaction is spontaneous in the forward direction, but if it is shifting to the left, what will happen to E cell? Cell will be decreasing, see, left, reverse direction. This is the situation and the explanation for these type of questions. If Q is greater than 1, log Q is positive, then in that case, E cell will be less than E naught cell because reaction will go in the reverse direction according to Le-Chatelier principle. You will get less cell potential because cell potential you are getting when the reaction is going in this direction. That's going to give you E naught cell. If it is going in the reverse direction because the products are more, then it will reduce the E cell. This is the explanation, chemistry explanation, where you are using Le-Chatelier principle. What is the mathematical explanation? This equation. Mathematical explanation. If log Q is positive because Q is greater than 1, then this answer will remain negative, isn't it? This will remain negative. Then what is E cell? Then in that case, E cell will be less than E naught cell because this number will get subtracted. So these kind of questions will be there. Is it okay? Can I start asking questions now? Okay, I'm going to erase everything. I'm going to give you one equation. Equation is something like SN 2 plus reacting with X solid, giving you X 3 plus and 10 solid. Can you balance this equation, children? First, balance it. You already know what is anode and cathode here. This is, what is this? Undergoing reduction is cathode, right? And what is this? Anode. Can you balance? How to balance? See the charges. Atoms are already balanced. What are we going to balance? Now the charges. Remember yesterday I told you. Yes. How to balance? Yes, Arnav, good. So this is going to gain 2 electrons. This is going to lose 3 electrons. So the common multiple is 6 electrons. So you have to make this charge as plus 6. Put 3 here. Put 3 here. Put 2 here. Put 2 here. Can you see the charges are balanced? Are they balanced? Okay. Now write down Q expression. What is Q expression? Q, the non-equilibrium state. This is aqueous. Aqueous. Q expression is concentration of X 3 plus raised to power 2. This 2. Yes. Vinaya good. Athava good. Divided by concentration of Sn 2 plus raised to power 3. It's a non-standard condition. Concentrations are not to 1 molar. Concentrations are different. I'll use the Nernst equation. E cell is E naught cell minus 0.0591 over n log q. I'm going to use this equation. And then this, okay, now the question is, if q is less than 1, what's the sign of log q? Hmm? Log q is negative. Good. If log q is negative, then E cell will be greater than or less than E naught cell. What's the relation between these two? If log q is negative, this negative and this negative will become positive. So E cell will be greater than E naught cell. Now this is mathematical explanation. Now can you explain if q is less than 1, then what is more in the reaction? The reactants or the products? Q is less than 1. The reactants is more. If reactant is more, in which direction the reaction will shift? The reaction will shift to the right. So they may ask you this. They may ask you, okay, give the mathematical explanation or explain with the help of Nernst equation. Nernst equation means mathematical. Or they will say that explain this with the help of Lee-Chatelier principle. Explain this with the help of shifting of equilibrium. So what they are asking, focus on that. If they are asking mathematically, use the equation and explain that minus minus has become plus. But if they are asking chemically, based on chemical equilibrium concept, then use your Lee-Chatelier principle to explain that reaction is moving in the forward direction. Moving forward direction means more reaction means more electricity. E cell will be more. We are understanding this, children? Okay, this is one concept. And if Q equals to 1, then what happens? What happens to log Q? Log Q will be 0. So what happens to E cell? This is 0, right? Will be E naught cell. So mathematically, you can explain this. Okay, now if Q is greater than 1, then log Q is positive and E cell is less than E naught cell. So we are good with this. Now the questions will be based on the Nernst equation like this. Not complicated questions. They will not ask you to do any calculation. They will ask you to predict. So we are doing this question now. This one. Read the question. Identify anode and cathode. Identify anode and cathode from the language here. When the switch is closed, the mass of the tin electrode increases. When I close this, the mass is increasing. So what is tin? Yes, see children, Atharva and Sanjana, Sanjana identified that this is cathode because the mass is increasing. Mass increasing means more tin is formed. If this is cathode, then what is this? Anode. We answered the A part, Kiki. A part is done. And how did you identify this? From the language which is written here. Cathode, they will decrease in mass. Anode will increase in mass. Okay, now let's see the B part. Yes, answer the B part. I want all of you to answer. It's very important. This question will be there. Just take it, it will be there. Yes. Arrow will be from anode to cathode. Yes, like this. So they are asking you to draw on the diagram. This diagram will be there in the paper. This is real exam paper. This will be there and you have to draw the arrow. So B part is done, A part is done. So we have already identified that this is anode. We already know electrons, they flow from anode to cathode. Okay, now let's see the C part. Answer the C part. And otherwise so fast. So anti-clockwise through. Yeah, okay, good. You know, anti-clockwise, clockwise, this language we are using more in organic chemistry. So when he said anti-clockwise, so I was just thinking about organic chemistry. Good. He's right. It's going like this, anti-clockwise. Don't use this word in the exam. Just say anode to cathode, right? And draw. If they are asking draw it. Okay, now how to calculate this? We know the equation. Equation will be given to you. E naught cell is E naught cathode minus E naught anode. You can see questions are very simple. You need to know the concept very well. That's it. What is cathode? Cathode is this value minus 0.14. What is anode? Question mark. That we need to calculate. Is E naught cell given? Yes. Plus 0.60 volt. Is it a galvanic cell or electrolytic cell? Nasya, is it galvanic or electrolytic? Mhm. It is galvanic. Give me two reasons. One more way is there. Can I identify as a galvanic cell from this picture? Yes, two compartments. Two compartments means galvanic. Salt bridge, two compartments. Yes, Arnav. Salt bridge is there. Voltameter. Voltameter. There is no battery. Voltameter. Electrolytic cell has a battery here, plus minus on the battery. But galvanic cell has a voltmeter to measure the amount of the current flowing through it. Current electricity is generated. Calculate E naught, anode. And I think what Atharva said is correct, minus 0.74 volts. So C part is done. Can we do this part now? This part? Now already know what is anode and what is cathode. This part, we are doing this part. E part. So now write down the equation the way it is needed. Cathode, you are going to write as such is reduction. Anode, you are going to write down in the reverse manner. Anode is oxidation. So X metal. In fact, if you check the reduction potential table, this is zinc metal. Oh, but zinc cannot have 3 plus. It's chromium, I think, not zinc. Chromium is chromium. This is chromium metal. And it's going to give you X3 plus aqueous and 3 electrons. Now you're going to add these two reactions after equalizing the electrons. Now I'm not writing it. I want all of you to do it in your notebook right away and give me the final equation here in the chat. Don't worry about aqueous and solid. Just write on the final reaction, final balanced equation. Waiting for the answer from everyone. Rahul, let's do it. And Dhruv is so fast. See what Dhruv is writing. Is it correct, children? If you're also getting the same, just put same, same, same. There's no need of typing because you're working in your notebook. Work it in your notebook. Yes, Vinaya, very good. Siri, Siri, nowadays you are not answering much. Good, perfect. Okay, so we have the equation, final equation. You're multiplying this by 3, this is becoming 6, 3, you're multiplying this by 2, and this is becoming 6. Now 6 electrons and 6 electrons cancelled. So you have 3Sn 2 plus 2x giving you 3Sn solid plus 2x 3 plus aqueous. That's the final equation. So this is a very popular question. Look at the half reactions, identify anode and cathode, and write the final equation. This can be a multiple choice question. This can be a free response question like this. So we are done with this first set of the questions, but we have another set of the questions. So let's come down. This is the another set of the questions. Now you already know the equation. The equation is 10 2 plus is there in the chat also. Reacting with X solid. Can you see what is the element? Remember the element? What was the reduction potential of that element? Minus 0.74 volt. Remember we calculated in one of the question. Can you identify from here which element is this? Which element has this reduction potential? Yes, it's chromium. So understand children, reduction potentials are identity of the element. So they may ask you some question, they will give you some part of the table, some part like this much part of the table, the way I posted here. They can also do that in the formula sheet. They will give you some part of the table. and they may ask you identify X element. So just calculate its reduction potential and pick up from here. You can see this chromium. You were getting accurately the same answer. Okay, then this is your 3 tin solid. So we did this part. Identify metal X, chromium. Okay, very important question. Now I'm coming on this part, first part. Can you just write down the Q expression? Can you give the Q expression for this? Q, non-equilibrium constant. It is the concentration, its expression is same as that of K. This one, we did it earlier also. Solids are not the part. Yes, like this, Arana, good. Now they have given the concentration changed from 1 molar to 0.5 and X3 plus changed from this to this. Can you calculate Q, children? Plug in these concentrations. X3 plus is 0.10 molar raised to power 2. 10 2 plus is 0.50. Read the question. Naisha is saying this value is 0.080. I'm going for 2 sig fig. No units is Q like K. K has no units. Q also has no units. Very good, Siri. Yes, Arya, no units. Okay, is this value greater than 1 or less than 1? Q is less than 1. Log Q will be negative. You remember the Nernst equation? E cell is E node cell minus 0.0591 over N log Q. Now you're saying this Q is less than 1. So what's the relation between E cell? See, do not do any calculations. Determining the cell potential, E node cell. So what is E cell? Greater than or less than? Yes. You already know E node cell. Remember in one of the question they mentioned, it is 0.60. So it means E cell will be less than 0.60 volt or more than. Oh, what is this? Sorry, it's more than because log Q is negative, right? So can I say that E cell is greater than E node cell? And E node cell we already know. You know the elements. It was given in the previous part. Yes, yes, good, Lassia. Dhruv, good. So can you explain this based on Lee Chatelier principle? Why? Explain this that E cell is greater than E node cell using Lee Chatelier principle. So start like this. Q is less than 1. So what is more? Reactants are more or products are more? Reactants are more. If reactants are more, in which direction this reaction will shift? It will shift to right. If it is shifting to right, means more products. More products means more cell potential. More reaction, more cell potential. Just take it that this question can be there in the exam. Yes, Dhruv. Yes, Sudeep, good. So that's the answer of the first part. Oh, second part also we have answered. Second part we have answered, right? Read the second part. Justify your answer. We justified in both the ways. Right now, they are asking you to justify by using Nernst equation, but we have justified by using Nernst equation and by using Le Chatelier principle. Both ways we have justified it. Then what is the answer for the first part? What is the answer for the first part? They are just asking you to plug in the values. So we have to come back to the first part again. Means you write on the Nernst equation E cell, E node cell minus 0.0591 over n log q. They are asking you to plug in the values. That's it. So what is E node cell? Plus 0.60. It was given to us. You can calculate also. One element is tin. This was the cathode. And this is the anode. Cathode minus anode. So answer is this. Minus 0.0591. What is n, children? How much is n? That you have to plug in. How much is n? Yes, it is 6. Who is this? Throw. Very good. 6 electrons. You can see that it's a transfer of 6 electrons. And you remember we calculated Q, this one. And leave it like this. No calculations. Now from here, just predict. So E cell will be greater than E node cell because log Q is negative, because Q is less than 1, and then keep explaining. Is it okay? And we are done with this concept of the Nernst equation. One last question which I'm generating and I'm thinking that it can be there in the exam. We call it as concentration cells. Concentrations cells. I'm making a galvanic cell. I'm making a galvanic cell. So I need 2 containers. They may ask you to sketch a galvanic cell. So I'm sketching a galvanic cell with 2 solutions. One solution in this. One solution in this. With 2 electrodes. One electrode here. Electrode, solid metal. Electrode, solid metal. I'm connecting them through the voltmeter to see the deflection, to calculate E cell. I'm taking known standard conditions. Concentration cells means known standard conditions. And then one more thing is needed, a salt bridge. Without salt bridge, this reaction, this cell will not work because solution will become electrically charged. Salt bridge is needed to neutralize the extra charges created in the anode and cathode. If this salt bridge is Na plus and Cl minus, then we'll see where these will flow. So I'm going to make the complete picture, okay? So let's see, what are the solutions? In one container, I have taken silver metal. In another container, silver metal. The solution here is 0.1 molar silver nitrate. And the solution here is 0.01 molar silver nitrate. So children, this is a galvanic cell. It can give you electricity. Can you see in both the containers, the half reaction is same. Half reaction is with silver and silver plus. This is silver plus, silver plus, silver and silver plus, silver and silver plus. But the concentrations are different. So there is a law in the nature. We are not following it in our In our society, we don't follow that. In the nature, they say everything should have that equal parts. If there is some high pressure in some area, then the air will go from high pressure to low pressure. If there is high temperature in some object, then heat will flow from high temperature to low temperature. Same with concentrations, osmosis, all these things, osmotic pressure, osmosis, they follow this rule, high concentration to low concentration. So same thing is here. Now what will happen? This will try to reduce this concentration, reduce the concentration, high concentration, right? And this will try to increase the concentration. Agreed? Increase the concentration. So you're not adding anything from outside, you're connecting them. So can you tell me how to reduce the concentration of Ag plus? By, yes children, by reduction. So what is this, anode or cathode? Cathode. If this is cathode, what is happening here? Then this is anode. And what is happening here? Your silver solid is undergoing oxidation. This silver solid is undergoing oxidation. Silver plus. Kiki, you are getting it? Kiki, you're there? Kiki. Oh, okay. So, fine. Kiki is saying she was not connected in between. Naisha, everything is okay? Anyone having any problem in understanding the concentration cells? Is there any problem in understanding this? Okay. Now this is a non-standard condition, non-standard. You see, I have given you different concentrations. The concentration is not 1 molar, is 0.1 molar here. So I'm going to use E cell is equal to E naught cell minus 0.0591 over N log Q. Yes, Dhruv, cathode is gaining mass. Same thing. You're getting silver solid. Cathode is always gaining mass. Just write on somewhere. On the cathode, metal ions, they gain electrons and they get deposited on it. Is it okay? So cathode is always gaining mass. Okay, children, now we are going to use this Nernst equation. It's a non-standard cell. Conditions are non-standard. Okay, so what is E naught cell here? First, let's calculate the E naught cell. E naught cell is E naught cathode minus E naught anode. This equation will be given to you. But what's the reduction potential of silver? Silver plus 1 electron, giving you silver solid. We are going to write on the reaction the reversible manner. It is 0.80 volt will be given to you. Can you now calculate E naught cell? Reaction is this. So what's the reduction potential of cathode? 0.80. What's the reduction potential of anode? 0.80. What is E naught cell? For all concentration cells, they may ask you this question, they may not. I'm not sure about it because they keep changing their ideas. So, but I felt that this is something what we are learning is related. We must do it. All concentration cells have zero potentials, zero E naught cell. Atharva, this negative is taking care of that. You remember I told you. Atharva is asking a very doubtful question. We don't flip the signs. Siri is right. Because this equation is only for reduction potentials. You are taking reduction potentials. And this minus is taking care of that. This minus is taking care of that flipping of the reduction potential for anode. So please just plug in the values as such. Okay, if you want to flip the sign, then the equation is different. Some teachers, they use it. E cell is E naught cathode. Take the reduction potential plus E naught anode. If you are using this equation, children, this equation, then you have to flip the sign of anode. But we are not using this. What we are using? This one. So why I have introduced this minus here? Because anode is the reverse reaction, right? Dhruv, is it okay? So be very clear. In the examination, don't try to flip your reduction potentials if you are using this equation. And I have seen from past few years, the AP College Board site are giving us this equation, not this one. They are giving us this equation. Okay. Okay, so now let's plug in the values. So E cell is E naught cell, which is 0.0 minus 0.0591. What is N here, children? N? NEC? Yes, check. What is N? And write down the final equation. The final equation will be silver plus aqueous. This silver plus is 0.1 molar reacting with silver solid. I'm adding both the equations, giving me silver plus aqueous, this silver plus, which is 0.01 molar plus silver solid. Look at the equation. Can you see the difference here? Equation. Ramsey is right, N is 1. But can you tell me what is log Q? What is Q? Can you get the Q? Work out the Q from this equation. Write down the balanced equation. So Q is the concentration of silver plus this one, this silver plus over concentration of silver plus this silver plus. So it is 0.01 divided by 0.1. And everybody's right. So is this Q log 0.1? Is this Q greater than 1 or less than 1? Q is less than 1. So E cell will be greater than E naught cell. We have done everything. I can calculate it without calculator. This is minus 1. Minus 1 times minus, what's the E cell value? Without calculator, you can do it. This is minus 1. So answer is plus 0.0591 volts. You'll get this much electricity. Children, you are getting it? This is about the concentration cells. So even cells which have the same kind of solution, same kind of electrode in both the containers, due to the concentration gradient means due to the difference in concentration, electricity will flow from, give the direction. Now let's complete it. From anode. What is anode? The low concentration one. Anode will be of low concentration. Electricity will flow from anode to cathode. And which one is cathode? High concentration. This is cathode. And in which direction Na plus will move? It will move, say, cation. It will move in the direction of cathode. And Cl minus is an anion. It will move in the direction of anode. Because anode is getting extra silver plus ion. And cathode is removing silver plus, is removing. The silver plus ions are removed. So Na plus will come and substitute it. So Na plus will come out of here. And here Cl minus will come out. That's the complete picture of your concentration cells. You can practice it. It's not difficult. Okay, I'm going to erase this now. We are coming on the last topic of this unit. That is it okay? Shall I erase it? I'm going to erase it. Now this is the last topic. Electrolysis and Faraday's law. Again, very important and very simple. So you already know that what is an electrolytic cell? An electrolytic cell has only one container like this. Both the electrodes are in the same container like this. But these electrodes are connected through a battery. You're using electricity. Battery has two terminals, plus and minus. The plus terminal will make this plus, will make one of the electrode positively charged. The negative terminal will make another electrode negatively charged. So you're going to talk about the charge now. Charge on this electrode and charge on that electrode. Now you're taking a solution or some ionic compound in the molten form. Let's say I have taken NaCl in the molten form. Now the question is why I need to take this in the liquid form now, why not in solid form? That can be a question. If I do with solid, no change, no reaction, nothing will happen. Yeah, give reason. Unit 4. NaCl solid will not do any changes in this container. Because in the solid, yes children, very simple. Is it a conductor of electricity? Solid. Because it cannot conduct electricity. Okay, what else? Yeah. Ions cannot move. Ions cannot move. Yes. So if they ask you this reason, then say, oh, in NaCl solid, it's a very compact structure. Particles are tightly packed. These Na plus and Cl minus cannot move, cannot conduct electricity also. So nothing will happen. But as I make it molten, molten means liquid form, liquid, they are free to move. Now let's see what happens here. Okay, check the charge on this electrode. What is the charge on this electrode? Positive. Check the charge on this electrode. What is the charge? Negative. Why is it so? Why they have these charges? because they are connected to positive and negative terminal of the battery. We all know that batteries have two terminals. This battery, right? Now, you have Na plus and Cl minus in the solution. Can you tell me in which direction your Na plus will move? Na plus will move in which direction? On which electrode? On this one, the one with the negative charge. Where the Cl minus will move? It will move on this one, where the positive charge. What Na plus is going to do? It's going to gain electron. It cannot give electrons. It has already positive charge. Going to gain electrons, right? And become Na liquid. What is this reaction? Reduction. Where it is happening? On the negative part. What this negative electrode is called as cathode. So you'll be tested for this. That cathodes have negative charge in the electrolytic cell, and all the cations will move in the direction. The one with the plus charge will move in the direction of cathode and will give you a solid metal, right? This is cathode. Where Cl minus will move? Cl minus will move on the positive terminal. What this positive terminal is asking? It's asking electrons. So it will undergo oxidation to give you Cl2 gas. That's the natural form of chlorine. Chlorine exists like this. What else is formed? Two electrons. So what is this? This is the anode. Oxidation. And how these electrons will be flowing in this circuit? It's always like that. Anode is oxidation, cathode is reduction, and electrons will be coming out of the anode. See, like this. Because these two electrons are traveling like this, up like this. And what is happening on the cathode terminal? Electrons are, this is negative, so electrons are coming out of the negative terminal and going in the cathode, and Na plus is gaining. See, this reaction is taking place. So that's the electrolytic cell. Working of the electrolytic cell. There is one container, anode and cathode. We are forcing reduction and oxidation. We are forcing them. How are we forcing them? By using electricity, battery. Okay, this is a non-spontaneous reaction. You are using electricity. You are trying to carry out a non-spontaneous reaction. If you see the E cell value, E naught cell for this particular reaction, this one, it will be negative. K will be less than 1. Delta G will be positive. So that is the reason you need a battery. With the help of battery, you are creating positive charge on one electrode and negative charge on another electrode. And that's how you are forcing this Na plus to undergo reduction. You are forcing it. Otherwise, Na plus is very happy. It's very stable. Okay. Are we clear about this picture? Can you answer my questions? Look at this picture. The same reaction we have done, the same reaction. Can you tell me what is the charge on this anode? On this anode, what is the charge? You can see Cl minus are moving. Charge on the anode. All of you, please. That's why Cl minus is moving. What is the charge on the cathode? That's why Na plus is moving in that direction. Na plus, right? Okay. Now, anode is oxidation or reduction? That thing is not going to change here. Anode is still oxidation. And cathode is reduction. That's not going to change. The same thing is there in galvanic cell and same kind of nomenclature we are using here also. Anode, oxidation, cathode, reduction. And that is what is happening over there. How the electrons will flow? Flow of the electrons. Show the flow of the electrons from anode to cathode or cathode to anode. Flow of electrons. Okay, I think. Children, if you feel that I'm speaking very fast, you can let me know. Yes. From where to where? It's already marked. Pay attention. Can you see? Now tell me how these electrons are flowing from anode to cathode or cathode to anode. Now, Rahul, explain. Because if you see, anode is the one which is giving you electrons. These electrons are going in the wire like this. These two electrons. And you can see bubbles of Cl2 gas. These bubbles on the anode. Right? And then they are going in the battery on the positive terminal of the battery. This positive terminal of the battery is applying a force, is pulling these electrons out. And for that, we need energy. So it's using its energy, electrical energy, to pull out the electrons from this anode. And then is forcing electrons to go in this cathode, where Na plus is gaining it. So remember, anode, cathode, same thing. Anode is oxidation, cathode is reduction. But electrons are, and the same thing is for the flow, anode to cathode. In galvanic cell also, anode to cathode. In electrolytic cell also, anode to cathode. Is it okay? So these are the questions which can be there. Let's see this one. This is the electrolysis of the water. But when we are doing electrolysis of the water, like in the first example, I picked up NaCl. And I said, okay, I'm taking NaCl as molten. It's an ionic compound, giving you plenty of Na plus, plenty of Cl minus, very strong, fully dissociated, right? But if I take water, you already know that water is not a strong electrolyte. Water is not 100% dissociated. It's not going to give you very large concentration of H plus and OH minus. It's not a good conductor of electricity in pure form. Pure water is not a good conductor of electricity. I have to make it good conductor. So what I'm going to do, I'll add some sulfuric acid. This sulfuric acid is a strong acid or weak acid? Sulfuric acid is strong or weak? Yes, children. Unit 8. Sulfuric acid. Strong acid or weak? Strong. So it's going to dissociate 100%, sorry, 100% to give H plus and HSO4 minus. You remember it's a diprotic acid, only breaking away of one hydrogen is strong. This is weak acid. This one is weak. This is not strong. Only removal of first hydrogen is strong. Removal of second hydrogen is not strong. If you remember, we discussed about Ka1, Ka2. Ka1 is more than Ka2, which is more than Ka3. So as you start deprotonating, as you start removing hydrogen, the species left is getting a negative charge. Removal of second hydrogen becomes more difficult because negative charge is holding that hydrogen more strongly. Kiki, you are there? This is Unit 8. We discussed that. Please do the quizzes on the website. Now it's time that you do the review quizzes. Okay, now I don't think you have plenty of time to do all the quizzes on the normal website. So just leave it. You can do, if you are getting time, do it, but I don't want you to be doing nothing later on because time was not there. So you start doing quizzes on the review website now. Do the quiz of chapter 7. There are 2, 3 quizzes. Do them, practice them 2, 3 times. Answers are also there. When you submit the free response questions, let's say you are not getting this free response, you submit it. Submit it and you will see all the answers. Then practice and check my answer is wrong or right. That's for you. That quizzes are for you. Don't worry. If you're getting 0, I will come to know that you have submitted without doing anything. Now you're checking your answers. Then check your answers. You can submit it 100 times. Okay, so please start doing review quizzes now. It's time to do review quizzes. Kiki, you will be doing this week. Try to finish all the review quizzes of the topics which we have done. Okay, it's very important. Fine. So now we have in the solution H plus, HSO4 minus, and water. These are present here. This is anode. So what is the charge here? Which terminal is this? What should I place here, plus or minus? Mhm. Yes, Vinaya, good. And here, minus. So it means anode has plus charge. Out of these 3, and cathode has negative charge. Can you tell me who will move in the direction of cathode? Who will move in the direction of cathode? H plus, HSO4 minus, or water? H plus, definitely, yes. And what will happen to H plus? It will gain electrons. And what is the standard form of hydrogen gas? H2. So I can say 2H plus gaining 2 electrons. This is the cathode reaction. Now, who will go in the direction of anode? Who will go? HSO4 minus and water. These two will go in the direction of cathode, anode. Nothing will happen to this, nothing, no change. Question is why? It has a negative charge, it should get oxidized because here sulfur is already in the highest oxidation number. Check the oxidation number of sulfur, +6. Now all the i's on the periodic table. Can you tell me how many valence electrons sulfur has? Take out your periodic tables. Check how many valence electrons sulfur has. Dhruv, Lasya, Saranya, Yes, Dhruv is right. 6. It is the oxygen family. It's 6. 6 valence electrons. So do you think sulfur can show you higher oxidation number than 6? Maximum it has only 6. So is sulfur capable of showing you higher oxidation number? And Siri is perfectly correct. No, it cannot show you more than plus 6. It's already in the highest oxidized state. And what is the charge on hydrogen? Plus 1. Can you check how many valence electrons sulfur has? Oh, hydrogen has. Look at the periodic table. And can you tell me what can be the highest oxidation number of hydrogen? It has 1 valence electrons and its highest oxidation number is plus 1. So even this cannot be oxidized, this cannot be oxidized. So this species will not participate. Who will participate? Water. And water will oxidize to give you O2 gas. Your oxygen is going from -2 to 0. There are 2 oxygens, so that's why it's losing 4 electrons. So definitely you have to multiply your this equation by 2. That's why the other reaction is this. Now you can add these two reactions, correct? To get the final equation. So when I add these two reactions, can you write down the net reaction? Net reaction. What is the net reaction? Yeah, please, all of you give me the net reaction. Add these two half reactions. Electrons are already balanced. They will cancel out. When you add them, these electrons are cancelled out. They have to be cancelled out. Waiting for the answer, Saranya. Perfect. Very good. That's the equation. Okay, so the net reaction is that water molecule is undergoing decomposition to give you 2 molecules of hydrogen gas with 1 molecule of O2. Okay, now look at this picture. In this picture, can you identify which one is your which one is giving you more volume of the gas? This is the amount of gas which is formed. All this is water. This is water. This is water. You know the gases are lighter, so they will go up. This is the amount of one gas, and this is the amount of another gas. So they have just given me this picture, and they are asking which one is anode, which one is cathode, where is hydrogen gas, where is oxygen gas. They are asking all these questions. So which one is hydrogen gas here? Is this one or this one? Okay, Dhruv is saying left and he's right. Can you explain why is it so? This is hydrogen gas. Why? Because hydrogen gas formed is more, double the volume of your oxygen gas. See the ratio? 2H2, 1O2. If you carefully look at the balanced equation, for every 1 molecule of O2 gas, I'm getting 2 molecules of H2. For 1 mole of O2, I'm getting 2 moles of H2. So this one is with where hydrogen is formed. And hydrogen is formed on the anode or cathode? See H plus undergoing reduction. So where is cathode? This is cathode. And where is anode? This is anode. And so what is the charge? What is this terminal of the battery? You can see there is a battery. You can see wires. So what is this terminal? Negative. This terminal, positive. So just by looking at the picture, this is the real way of collecting them. I cannot make hydrogen gas and oxygen gas in a container like this. You cannot do like this. Why? Because they are very reactive. Hydrogen gas is very reactive. It reacts explosively with oxygen gas to give water. So you cannot carry out reaction in this kind of setup. You need to be very, very careful, and you have to make a setup where you are collecting your hydrogen gas and oxygen gas separately. They should not come in touch with each other. Is it okay? Okay. Now, the very last part is how to convert. You are using electricity here. How to convert the electricity into amount of the substance. See this one. So I'm going to explain you this with the help of an example. Before we start, what is current? Its standard SI unit is ampere. It is the rate of flow of charge, means rate of flow of charge, means charge divided by time. Current I will be representing as I, charge as Q. This is charge. This is not that Q of the non-equilibrium state. That is different. This is different. Time is seconds. From here, I can say that Q is I times T. Can I say that? Once I know the charge, I can convert this into moles of electrons. Once I know the moles of electrons, I can get moles of matter, and I can convert moles of matter to grams of matter. How can I do that? Because we know that Q and moles of electron, we know this relation that 1 mole of electron is Faraday's constant 96,000. We discussed this yesterday. We know this relation. How to convert moles of electrons to moles of matter? From the balanced equation. Like for example, you are doing reduction of calcium 2 plus. Okay, Kiki. It's going to give you calcium solid. So what is the relation between moles of electrons and moles of matter? That 2 moles of electrons can give you 1 mole of matter. Once you have moles of metal, you can convert that into grams of metal by using periodic table, molar masses. Ready for one question? Is this clear? This part? This dimensional is clear? This one? Okay, I'm going to show you now more clearly. See here. So, you're going to multiply current with time. Take care, current should be in amperes and time should be in seconds. It should be in seconds, SI units. If it is not in seconds, then convert that into SI units in seconds. You will get Q in coulombs. Convert that Q into moles of electrons by using this ratio, this one. Once you have moles of electrons, get the moles of substance. Good, Kiki. And once you have the moles of substance, get the grams. Okay, ready for one question? So I will not be helping you with the question. People are going to do it on your own. So here is the question. Sodium metal is getting formed on the cathode. This is cathode reaction, reduction. Remember we discussed this particular reaction. I'm writing liquid here. If the amount of current given is 20 amperes for 60 minutes, can you calculate the grams of sodium in that can be formed in that electrolytic cell? So 20 amperes, 60 minutes is given. This is the equation. This is the amount of the current and time. You will take current multiplied by time in seconds. That will be your coulombs. You will convert the coulombs to moles of electrons. You'll go from moles of electrons to moles of sodium by using the above balanced equation, and then you can get the grams of sodium. You can do it in one single line as dimensional. Start with what is given, 20 times 60. Is there any problem with the unit? Yes. Convert that into seconds. Now this is coulombs, this one. I times T in second is coulombs. Now you plug in the next ratio, plug in the next ratio, plug in the next ratio, and you'll get grams of sodium. Who is going to tell me? What should I plug in here? I want to convert my coulombs to moles of electrons. So what do I know? I know that, yes, children. What do you know? What's the relation between these two? What is this number? Yes, 1 mole of electron divided by 96,500 coulombs. Next ratio. Yes, Dhruv, next ratio. Rahul. Kiki. Naisha. Moles to moles. And otherwise saying 1:1. He's right. 1 mole of electron giving you 1 mole of sodium. So I'm writing 1 mole of sodium over 1 mole of electron. Next ratio, please. Look at the periodic table now. Yes, Sudeep, good. Look at the periodic table. Siri, start answering. Saranya. Yes, I can take 23 grams. 23 grams of sodium divided by 1 mole of sodium. And that's the answer. Check all units are cancelled out. Very popular question. All units are cancelled out and you are left with grams of sodium. And take care, I have given you one sig fig here. I didn't place any decimal. So answer should be in one significant figure. So what's the final answer? Plug in like this in your calculator. And you'll get the final answer and put your answer in one significant figure. What is the answer? Ashita, you're also not answering anything. Children, from my side, if you're not answering, then it means you're not listening. $17. Yeah, if I want to put this in significant figures, 1 sig, then it is 20 grams. Okay, good. So I'm going to clear this. Ready for this question now? Let's do this question. The volume of hydrogen and oxygen gas at STP by the electrolysis of water. So what's the reaction of electrolysis of water? Now the reaction is not given. Do you know the reaction of electrolysis of water? Yes, breaking down of water into hydrogen gas. Remember, we did all these things here. 2H2 gas and O2 gas. What do you know about STP? Remember yesterday I was telling you the difference between STP and standard condition. STP means 1 atm pressure, temperature 273 Kelvin, and yeah, no, Nivriti, no. Nivriti, can I ask one question from you? Yesterday also you joined quite late, isn't it? Are you busy in something? Today also you are nearly 1.5 hours late. Nivriti. So please, okay, children, now it's very high time that you can leave the events for some time, okay? At least for 10-15 days. Take care of your AP chemistry, otherwise it's a waste. AP chemistry is like mathematics. You don't practice, listening is not the solution. Listening will not give you anything. Practicing will help you. 1 atm pressure, this is the temperature, and what else? 1 mole of every gas is 22.4 liters, right? Okay. Now you have 2 moles of hydrogen gas and 1 mole of oxygen gas. There is one more law, if you remember, equal moles, Avogadro's law. Equal moles have equal volumes at the same temperature and pressure at the same unit 3, same temperature and pressure. Now, these are equal moles? No, this is 2, this is 1. If I say the volume of oxygen gas is V, what will be the volume of hydrogen gas? 2V. Agreed? This is Avogadro's law. Equal volumes have equal moles. And if moles are different, volumes are different. So you can read the equation in terms of volume because this reaction is taking place at the same temperature pressure. So I'm going to use these two concepts to solve this question. Ready? So let's start with the amount of the current and time. So I'll convert my I and T, first T into seconds. I'll get the coulombs. I'll get the moles of electrons. and I will get the moles of any of these gas, any. So let's say moles of hydrogen gas. Once I have the moles of hydrogen gas, I will get the volume of hydrogen gas. This is my plan. If I have the volume of hydrogen gas, I can get the volume of oxygen gas. So I'm planning this. Is the plan okay, children? Okay, fine. So let's do it. I need some space. Okay, so let's do it. So what is I? 2.50 amperes time 15.0. I'll take 3 sig fig. Both the numbers are in 3 sig fig. Final answer 3 sig fig. And this is minutes, so I'll multiply it by 60. Now it is coulombs. Plug in the first ratio. Yes, 1 mole of electron. What is the first ratio? Coulombs to moles. 1 mole of electron over 96,500 coulombs. Plug in the second ratio. Second ratio. Moles of electrons to moles of hydrogen. So you can use this equation. This one. 4 moles of electrons are giving you 2 moles of hydrogen. So I'll plug in that here. 2 moles of hydrogen gas over 4 moles of electrons. Or the way Naisha is saying, because this 2 over 4 means 1 over 2, right? Sanjana, 1 over 2, right? Yes. 2 over 4 means 1 over 2. You can write this equation like this also. 2H plus gaining 2 electrons, giving you H2 gas. Remember, we multiplied by 2 because here 4 electrons are there. So just to make these 4, we multiplied by so that we can add them. You remember that? So you can use this one, no problem. You'll get the same answer. Times. Now you have the moles of hydrogen gas. What do you want? Volume. What do you know? This STP condition. You know this. You can see my pen. So I'm going to say 22.4 liters over 1 mole of H2. Stop here. Stop and calculate. 2.50 times 15.0 times 60 times 1 times 2 times 22.4. Don't leave any number. In the one of the class, I did error in plugging in some numbers and we were getting wrong answer. Just check that I have picked up all the numbers from the numerator and the denominator. And the final unit will be liters of H2. And you are giving me up to 3 significant figures, 0.261 liters. How much O2? How much O2? Plug in the next ratio. This answer is 0.261 liters of H2. Plug in the next ratio. What is the next ratio? 2VV means 1 volume of O2. You can put 1 here. 1 volume of O2 divided by 2 volumes of H2. VV cancel 1 over 2. Yes. Naisha is already answering it. Just divide it by 2. You need not to show it. You have to simply say the volume of HO2 will be exactly half of the volume of H2. 0.131 liters of O2. A good question. It's not the real AP question. This I picked up from the book just to give you a review of STP condition, how to relate everything. And here comes the real AP question from this set. This is the real AP question. Look at the picture. Is it electrolytic cell or voltaic cell? You know, galvanic cell is also called as voltaic cell. Is this electrolytic or voltaic? Electrolytic. What is this? This one. What is this? Anode or cathode? See, reaction is given. Yes, it is cathode. Yes, very good, Nivriti. And what is this? It is anode. What's the charge here? Nasya, what's the charge here? Minus. What's the charge here? Very good, Siri. What's the charge here? Yes, Arnav. Very good. Plus. Arya, good. How the electrons are flowing? Give the direction of the flow of electrons. Why you people are so quiet when I ask the flow of electrons? It's so simple. It's always fixed. Yes, always anode to cathode. You people become very quiet at that time. Is there any confusion? Memorize it if confusion is there. We don't have time now. Okay? If you feel that, oh, what, just memorize. Right? Now, this is the reaction which is happening over there. You can see this table. So we have identified cathode, anode, minus, plus, electrons flowing like this. Oh, we did answer A part, right? Can you see the A part? Here. We have answered A part. Indicate the direction of electron flow in the wire. This anode to cathode. We are going to write B part. Now you already identified that this is cathode, right? So it means the other one is anode. I told you that when you have to write down the complete balance equation, write these reactions in the right format. Cathode reaction as such, copper 2 plus 2 electrons. Reduction, cathode is reduction. So I'm taking this one as such. For the anode, I will reverse the equation. And then to get the final equation, I'm going to add them together. After checking the number of electrons, they should be equal. So what should I do? I want to add them. I have to make these electrons equal. So electrons are not equal, right? One is losing 2, other one is gaining 4. And it's a redox reaction. They are exchanging electrons among themselves. Nobody else is coming. So if this needs 4 electrons, then the first reaction has to be multiplied by 2. Now you're ready to add them. Cancelled. Now whatever is left, Cu2 plus aqueous. Ions are in aqueous, in water. And H2O liquid, giving you O2 gas plus 4H plus aqueous plus Cu solid. Is it okay? That's the answer of the B part. This is something which is important. For the galvanic cell, for the electrolytic cell, they may ask you this type of question. This question is in 2007. Don't worry, it can be again. It's a very popular question. And as I said, every year in the free response, there is one question from acids and bases, one question from your thermochemistry and thermodynamics, one question from your Lewis dot structures, and one is from electrochemistry. And of course, other things they try to mix up the other things also. But these are the 4, 5 set questions. Okay, now let's see. C part. Can you answer this without my help and justify? Yes, Atharva, very good. Justify. It's an electrolytic cell, children. You are using external battery. You're using power supply. You're not getting electricity. Yes, Naisha. We are using electricity. It's a non-spontaneous reaction. Yes, Arnav. Good. Can you see questions like this? They are so simple. Okay, now moving on. Can we do the D part? You already know who is anode and who is cathode. How to calculate delta G naught value? How to calculate delta G naught? By using an equation which will be given to you in the examination as minus NF E naught cell. Yes, very good, Vinaya. But do I have E naught cell? I know that this is anode and I know that this is cathode. So what is E naught cell? If you remember, you are taking reduction potential, children, reduction potentials. So it is E naught cathode minus E naught anode. So 0.34 minus 1.23. Is this answer negative? Yes. A negative answer, Nivriti, indicates it's an electrolytic cell. You are doing non-spontaneous reaction, right? Plug in this value here. What is N, children? N. Give me the value of N. Remember, we have written the balanced equation here. Yes, it is 4. Very good. It's not 2, it's 4. What is F? Arya, you're understanding everything? Because you missed some part. Kiki, I cannot see your answers, dear. Now it is there. 96,500 and E naught cell is minus 0.89. Get the answer. And the minus will become plus. And give me the units. After Ashita, after calculating, give me the units. Who else is not answering? Answered. Sarayu, you're not answering, dear. Sudeep, you're there? Sudeep, you're understanding everything? Okay. And Nivriti is saying 344 kilojoules. But before that, what was the answer, Nivriti? Was it in joules or kilojoules? When you do this calculation, your answer will be in joules per mole. But that will be a big answer. And we are working for 3 significant figures, not 3, this time 2. Can you see? This 0.89 has only 2 sig fig. 2. So answer will be 340 kilojoules. Yes, Ramsey, you're right. Okay, good. So that's about your this part, how to calculate delta G naught. We are doing the next part. I'm going to clear it. Can we do this part? So I'm going to give you the equation for the reduction of copper. So there was copper 2 plus which was getting reduced at the cathode. Cathode is reduction. So this is happening at the cathode. They are asking how many grams of this is going to get deposited. So what is given? Amperes and time. So you will multiply I with T, you will get coulombs, you will convert that into moles of electrons, you will convert moles of electrons to moles of copper metal to grams of copper metal. Can you give me the final answer? I've given you that thinking, the planning, you call it as planning. Now you just convert this into a dimensional form and get the final answer. I'm not explaining. So please, if you have not understood, see what I'm doing. And those who have understood, do your own work. Keep checking. Are you correct? Take care of everything, of the units, of the time. It has to be in seconds. Then it becomes coulombs. Right? Next ratio. Look at the balanced equation. Always remember this. When I'm checking mole to mole, I have to look at the balanced equation. No confusion. In unit 1, we'll be doing these things. At that time also, when you want to go from moles to moles, balanced equation is the only option. Moles to grams, periodic table. Get your answer in 3 significant figures. Atharva is already giving us the answer. Atharva, what's the atomic mass of copper? 63 point. I don't have the periodic table with me. 63 point what? 546. Okay. Never consider atomic masses, molar masses for significant figures. Answer will be in 3 significant figures, children. So 1.19 gram. Everybody has understood this? Very popular questions and not difficult. Can we do this? Calculate the volume of the O2 gas. You remember the, can hear me? Am I audible, Kiki? Yeah, okay, good. Remember the final equation, the net equation. In the net equation, you multiply this by 2, this become 4. It was like this, 2Cu2 plus with 2H2O liquid giving you Cu solid plus 4H plus aqueous O2 gas. Remember, this was the overall equation. We did it. If you have the moles of copper solid, you can get the moles of O2 gas. So I'm not going to use this calculation again. So what I'm going to do, I'll stop here, get the moles of copper. So how many moles of copper are there? Just do the calculation up to this part, or divide this number by 63.546. You will get the moles. Get the answer in 3 significant figures. You're understanding why I'm getting these moles of copper? Answer is 0.0187. These are the moles of copper. I'll convert these moles of copper to moles of oxygen by using this ratio. 1:1? No, this was 2. You know, 2 here, 2 here. So what is the ratio? 2:1. So convert these moles of copper to moles of oxygen gas. Mole to mole, look at the balanced equation. Mole to mole, look at the balanced equation. So the moles of oxygen will be exactly half of this number, which Sudeep is telling us 0.00. Atharva and Sudeep are giving me the same answer. So I take it that is right. I'm not doing it. These are the moles of oxygen. Now read this part. What are they asking? And why I calculated the moles of oxygen for this part? Anyone? Mhm. They are asking to calculate the volume. They have given the temperature, they have given the pressure, and I calculated moles. So what should I do? No, Vinaya, this is not STP condition. Is this STP condition, Vinaya? You can use 22.4 liters at STP. I cannot use. So what should I use? Children, go back to unit 3. PV equals to, yes, Sudhi, nRT. What I want? V. I have N. R will be given to me in the examination. T given in the question over P. Ideal gas law. Yes, Kiki. Good. So, what is N here? This one. We are going to use for oxygen. This is a gas law. Don't try to use it on copper, okay? Copper is solid. Gas laws are only for for the gases, not for solids and liquids. Please do not use on them. I have seen AP testing you for this also. Some students, they use gas laws everywhere. No, no, it's only for gases. N is 0.00935. Temperature is Kelvin. All the gas laws, everywhere, temperature has to be in Kelvin. 298. R has two values. I'm going to pick up this value this time. 0.0821 liter ATM per mole per Kelvin. I'll use that value. And what else was there? P, 1.16. Put your answer in 3 significant figures, and Naisha is saying the volume is 0.197 liter. Is she right, children? Check. Arya is also giving us the same answer, so she's right. Yes, good. Perfect. And that's the end of your unit 9. So whenever I'm starting a new unit, I'm always asking you, let's memorize here only. Let's practice. Pick up your pen, speak loudly, practice some words. But when I say this is always like this, memorize it. A current, electricity flows from anode to cathode always. Anode is always oxidation, cathode. These things, keep memorizing them. Why should we waste our time again in understanding everything again and again? Why can't we practice right now? Those who are not answering. Those who are not answering, I'm taking that they are not doing anything. Okay, please answer here. Arana, You're not answering anything. Arana, even if you know the topic very well, please don't go away from your computer. You are here, you are in attendance. Arana, are you there? So you didn't answer anything. Okay. So start answering. I'm starting unit 5. Let's learn. We are going to practice, we are going to memorize, we are going to learn, we are going to fight for everything. Okay? Be a good fighter. Okay, Ashita, come back fast. So these are the topics which we have to do. So I'm starting with kinetics. I have placed many questions here because this topic is simple. It's better to learn it with the help of questions. These are the multiple choice questions from something like, I cannot say that real AP exam because you know that multiple choice questions of the real AP exams are not available. Only few examination papers are there which they have released. These AP exam people have released only 2 or 3 papers in 5 6 years. So that we are going to do. But these are the very things similar to AP exam. Ready? Okay. So first of all, what is the meaning of kinetics? Anyone? Kinetics. Kinetics means motion. And how I'm using this motion in the chemistry? In chemistry, it is rates of reaction. What's the meaning of rates? Rates means how fast or slow is a reaction. That's the meaning. How to know the fast and slow reaction? Because during a chemical reaction, there is a change in the concentration of the reactants and products with time. So, this change in concentration of the reactant or of the product will tell you the rate of the reaction. If the change is very high, very large change in very less time, then rate is high. If the change is very less in more time, then rate is slow. Some reactions are very slow. They need years and years to take place. Some reactions are very fast, explosive, within microseconds they happen. In our biological system, reactions are very fast, very, very fast. Okay. But outside in the nature, where many reactions are happening, but they are very slow. So that's what you are going to learn in kinetics. So let's start with this meaning over here, this one. So reaction rate, when I say what is the rate of a reaction, it is the change in concentration of the reactant, which is always written with a negative sign because reactants are, they are getting formed or they are disappearing. Reactants are disappearing. Can you see these black reactants? Finally, the reactants are very less. They are disappearing. That's fine. We put a negative here because if the change in concentration here will be negative. Let's say this is 2 molar. Let's say this is 1 molar. I'm just giving a random value. So what is, and the time taken is how much? 60 seconds? 60 seconds. See here, starting from here, going back to here. So what is minus delta E over delta T? What is it? It is always the concentration of the final minus concentration of the initial over time taken, which is 60. And there is a minus needed here in front of it. I'll tell you the reason. This minus, I'm going to retain. So it is minus, what's the final concentration? 1 molar, 1. Was the initial concentration 2 molar divided by 60? So what is it? What's the answer? Plus 1 over 60. Units? What are the units? Molar per second. That's the rate. We need to put a minus here because rates are never negative. Rate has to be positive. So that is the reason if we are working with the reactants, we put a negative so that we get our answer as positive only. And the units of the rate are molar per second. Are we clear about it? Okay. Now let's have a look at this particular reaction, this one. A is going to be B. You just calculated the rate of disappearance of A. We just calculated. What was it? 1 over 60 molar per second. We calculated, right? Can you tell me what is the rate of appearance of B? Appearance of B. If 1 mole of A disappears, 1 mole of B appears, what is the rate? Yeah, it is plus delta B over delta T. What's the value? The same, 1 over 60. 1 is to 1 molar per second, right? So from the balanced equation, you can compare the rates. So I'm giving you one example here. This is one first type of question. Everybody is clear about it? So you will look at the balanced equation. See here, this part. Answer my question for this from this part. I'm asking question from my side, children. If the rate of appearance of B, of this B, is 2 molar per second, can you tell me what is the rate of disappearance of A? Yes, Nivriti, very good and very fast. It's 1 molar per second. Yes, this is first set of questions. Okay, so, and if we have a complicated equation like this, so many coefficients, then whatever is the rate of disappearance of A, let's say it is 5 molar, let's say it is 6 molar per second. Can you tell me what is the rate of disappearance of B? What will be? Disappearance of B. Yes, it will be. See, look at the equation. Don't worry about this part. Look at the equation. What it will be? 12 molar per second. Yes. Here also, if you take this 2 on the other side, take this 2. You can see the coefficient 2 here. When I take this 2 on the other side, it will be 12. What is the rate of appearance of C? 18 molar per second. Start using units, Dhruv. Otherwise, you won't be able to practice it. Okay, molar per second. Yes, Rahul. And what about D? Yes, same. So now I'm giving you different questions based on it. Let's do them. One question is here. Okay, let's do it. Oh, Atharva has already answered. Look at the balanced equation. So those who have, now this is a difficult thing how to do it. So what you have to do, that you write down minus delta O3 over delta T. Take this coefficient here in the denominator is plus 1 over 3 delta O2 over delta T. What are they asking? Appearance of O2 means this thing they are asking, this thing. So it means delta O2 over delta T is 3 over 2, rate of disappearance of O3. And that value is given, this one. 9.22 times 10 raised to power minus 3 molar per second. Solve it. Yes, Arnav, very good. Atharva, good. See, Arnav, Atharva has done it so fast. Those who have not understood directly, they can do like this mathematics. Sometimes it happens that we are unable to do relate mathematically without writing. Yes, Saranya. So ready for another such question? Answer this. So what is given to me is the rate of disappearance of this here. What are they asking? The rate of formation of this. So the rate of formation of Br2 over delta T is, yes, this coefficient will go up, this one. It will be 3 over 5. Am I right? Oh, you people have done it. I'm still writing and you have done it. So I'm working for those who are not able to understand. Is it okay to all of you? Atharva is saying A, Rahul is saying B. Who is right? Plug in the values. Is B right or A right? Dhruv, can you confirm? Dhruv, who is right? A is right. Because the answer is 1.08. Can you see? Such confusing answer. 1.08 means not this, this. Okay. So that's about how to relate the rates of disappearance and appearance in the examination if some question is there based on it. Now I'm going to discuss different types of rates because there is no question on it. How to determine the rates of the reaction experimentally. So what they do that they start the reaction. You can see the data here. You'll be doing plenty of experiments in this particular unit. You can see here time. And the concentration of Br2. If you look at the graph, you draw the graph of concentration versus time. You're not getting a straight line. Are you getting a straight line? No. If we are not getting a straight line, it means the change in concentration is not uniform. The slope is not constant. What is the slope of this line? The slope of the line will be delta y over delta x. In mathematics, we call it like this. What is delta y? Delta concentration of Br2 over delta T. But that is the rate Br2, change in Br2 per unit time. The slope is negative. You can see line is negative, negative. But that's the definition of the rate. And this, if the slope is constant, if it is constant, then you get a straight line. Right now, it's not constant. You have to understand all these things because there will be questions based on it. It's not constant, you can see. So it means the slope is not constant. If this is not constant, it means the rate is not constant. Rate is continuously changing. If I draw a graph of rate of the reaction, which is this, versus concentration of Br2, the graph will go like this. Now I'm getting a straight line. because rate is directly proportional to the concentration of Br2. This is a different graph. This is a different graph, children. This one is concentration versus time, and this one is rate versus concentration. So they are two different graphs. So if the rates are not constant, how to calculate it? There are two ways. Average rate means the total change in concentration. Let's say I start from here, time is 0. This is the initial, and I go up to here. This is final. So final minus initial divided by total time taken. That will give me the average rate of the reaction. This is one way. Second, how to calculate instantaneous, which is more accurate. You draw the graph of concentration versus time, and for instant, like for example, you want to calculate at 100 seconds. So drop a perpendicular like this here. Draw a tangent, get the slope of the line, slope of this tangent, and that will be the rate. No one is going to ask you to draw this in the examination. They may not ask you to draw the tangent and get the slope and get the answer. No. But you should know the meaning. You should know how to do it. That's it. For the instantaneous rate, you pick up the time and you draw a tangent at that time, and that tangent is going to be a straight line. Get the slope of the tangent. That you should know. That's it. No calculations. Okay, now I have a different question. See here, children. This question is very popular question. A is getting converted into B. The reaction is going like this. This is concentration of A. This is time. C is getting converted into D. The reaction is going like this. This is concentration of C versus time. So they will show you these two graphs and they will ask you which reaction is faster, A to B or C to D. Very popular question in multiple choice. Which reaction is faster? Yes, Dhruv, Arya, that's the right answer. Can you explain? Yes, Saranya, good. Sanjana, why? If they say explain why. Because the change in concentration is more here in less amount of time. Yes, Saranya. So take care. This can be one of the question. Everything good? So that's about your introduction of kinetics. Now we are going on rate laws. We are going to learn different types of rate laws. One is normal differential rate law. We are not using this word differential, but they are differential rate laws. Then integrated rate laws, that concentration versus time. And then mechanism-based rate laws, elementary reactions, mechanism, stepwise, and working out the rate laws from there. Three different ways. Okay. So let's start with the first way. I'm expecting that I can finish this first one today. No answering, Dhruv, Atharva, just wait. So first of all, we are doing plenty of multiple choice questions. So whatever is written here, that's going to help us. First, rate laws are always determined experimentally. You cannot look at the balanced equation and work out the rate law from there. Remember this thing. So multiple choice question will be there. Second, They are always in terms of the reactants, never in terms of the products. Never in terms of the products. Reactants, you have to pick up the reactant. Third, like for example, this is the reaction. So I will say rate equals to K times concentration of F2 times concentration of ClO2. I will write X and Y. These are called as order of the reaction, order. Now you have to determine this order experimentally. You can see the data given here in the question. These are the experiments. What are they asking? What's the rate law? They're asking what is the rate law? Experimental rate law is, they're asking that. So I have to pick up one answer. Are you understanding this? So let's come back on the introduction now. Here, if there is a reaction, then you are always going to assume the rate law equals to K. K means the rate constant. It's not equilibrium constant. It is the rate constant. Concentration of A raised to power X. A is the reactant. Concentration of B raised to power Y. X and Y, they are called as order of the reaction. And the total order of the reaction will be this, sum of these two. Order can be 0, order can be 1, order can be 2. When I say order is 0, then it means when you double the concentration, when you change the concentration, 0 means you change concentration, change or double. Let's say you are doubling the concentration. You double the concentration, double concentration. There is no effect on the rate. Rate still the same. No change in the rate. No change. That is zero order. First order, when you double concentration, what happens to the rate? Rate will get doubled. Rate will become twice. If I double the concentration of A and my rate is also getting doubled, then I'll say, oh, this reaction is first order with respect to A. Second order means when you double the concentration, what happens to the rate? It will become quadruple. 2 raised to power 2. Quadruple. This one is D here. Quadruple. Quadruple means 4 times. You're understanding this? I picked up the example. I said double the concentration. You can say triple. If I triple it 3 times for the zero order, no change. Can you see? I'm just using a different language now. I tripled the concentration, and if there is no change, you can say zero order. If I triple the concentration and rate becomes 9 times. Oh, no. This is first order, right? In the first order, 3 times. You triple it, rate also increase by 3 times. But in the second order, if I triple it, rate will increase by how many times? 9 times, 3 squared. Okay, ready for the questions? Okay. So as we are doing questions, you will understand more better. These are multiple choice questions. Answer this question. Rate laws are always in terms of the reactants, never in terms of the product. So what all is cancelled out? D cannot be, E cannot be, B, all these cannot be A's answer. Yes, very good. This is from here. See this part. Very popular question again. Check this one. So this N and M, what are they called as? Order. So can you determine the order by equation? No. By formulas? No. By chemical formulas of the coefficient? No. By educated guesses? No. By experiment? Yes. See, rate laws are determined experimentally. Okay, I'll do that. Give me 1 second, children. By the time, can you see the next question? I need 1 second. I'll be back. Ready for next question? So this one. Naisha is saying C. Okay, let's see. How come it is C? So now children, yeah, Kiki is also saying C. Ashita is saying C. So first of all, you assume the rate law. Rate law is K times concentration of this reactant, raised to power X and Y. So every time, the first thing is assume it. Okay, 3 minus is in the center, in the uh, brackets, and raised to power X. And concentration of I minus raised to power Y. Right? Okay. Now look at experiment 1 and 2. So we are not interested in these things. Just ignore them. They are the products. We are not interested. So when you double the concentration of I minus, what is happening to the rate? Rate is also doubled. See, doubled. So what is Y? Y is equal to 1. First order. When you double this is getting doubled. So first order, Y is 1. Correct? Anyone have any problem? Otherwise, you can do it like this. Plug in the value of rate. What is rate? This one. K, don't plug in anything. Then plug in this concentration raised to power X, this concentration raised to power Y. Then say, take the second rate. Then take the ratio of rate 1 with rate 2. And then you will see, you will get the answer Y equal to 1. Do you want me to show you that mathematical form? Anyone have difficulty in understanding like this? Then we can do the mathematics also. And according to mathematics, rate 1, which is 1 times 10 raised to power minus 5, is equal to K times concentration of FeCN6, that is 0.01 raised to power X, and I 0.01 raised to power Y. This is rate 1. Get the rate 2. Second experiment. 2 times 10 raised to power minus 5 is equal to K concentration of FeCN6, which is same. And this is 0.02 raised to power Y. Now take the ratio of rate 2 with rate 1. Take the ratio. Means this divided by this. How much is this? 2. Take the ratio of these also. K is the rate constant, which is going to be same. It depends only on temperature and activation energy. Only activation energy and temperature can change it. Nobody else can change it. So what is it? 0, 0.0. This also cancelled. They are same. So you have 0.02 raised to power y over 0.01 raised to power y. So it is 2 raised to power 1 over 2 raised equal to 2 raised to power y. So what is y? Y is 1. Exponential mathematics. So either you do this if you are not able to understand in that manner. Arya, you're there? Ashita? Okay, good. So when I picked up experiment 1 and 2, I saw that this is same, so they cancelled. So when I double this, the rate is getting doubled, so first order. Now to know x, which two experiments should I pick up? Now the aim is to know x, get the value of x. Which two experiments should I pick up? 2 and 3. Yeah, okay. See children, 2 and 3 is okay. Yeah, good. See 2 and 3. This is doubled. This is cancelled. What is happening to the rate? It has become 4 times. So 2 raised to power x is 4. So what is x? 2. So which one is the rate law here? Oh, okay, sorry. Now y was 1, x is 2. Pick up the answer. So everybody was saying this, and they were right. So I still solve the equation both the ways because there are plenty of such questions which we have to do. Either you understand in this manner, and if you're unable to solve it in this manner, then do the mathematics. You'll get the same answer. Ready for another? Let's do one more question. Every time the first step is that you assume the rate law in terms of the reactants. This one, children. This is a very different question. So first I'm going to assume the rate law. Rate equals to K times concentration of this reactant, CH33 CBr, stirred butyl bromide, OH minus. Raised to power x, raised to power y. This is the assumption. K is the, what is K? Rate constant. Now get the value of x and y. Use these 3 experiments. You cannot use fourth because this value is not given. Use these 3 experiments. If I use experiment 1 and 2, this is doubled. This is doubled. So what is x, children? Yes, Dhruv, what is x? X is 1. See, so easy. Okay. Now I'm going to take 2 and 3. Not 2 and 3. Which 2 experiments should I take? I will take experiment 1 and 3. Then this is cancelled. And this is doubled. And what is happening to the rate? So what is y? Yes, Vinaya, very good. No change. So this is 0. So what's the rate law? K times concentration of CH3 thrice, yeah, third butyl raised to power 1 is first order kinetics. Yes, Sanjana. Sudeep, you're there? You're understanding this, Sudeep? Okay, good. Now I know the rate law. Now they're asking me this question. See, What will be the initial rate in experiment 4? Initial means when the time is just started, 0 time. You are just mixing them initially. So rate equals to K times concentration is given 0.30. What else is needed? I need K. Do I have K? Can I calculate K? Yes. Pick up any experiment. Pick up any experiment, 1, 2, 3, any one of them, and get the value of K. So rate equals to K. I'm picking up experiment 1. Just take experiment 1. Plug in everything. I'm going to plug in this and going to plug in this. It is 0.10 raised to power 1 and the rate is this much. 1.0 times 10 raised to power minus 3 molar per second. What's the K? K is 1.0 times 10 raised to power minus 3 divided by 0.1. And the answer is 0.01 units. You know, this is also molar, right? This is molar per second and this is molar. No, 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 no. It's not equilibrium constant. It is the rate constant, dear. Naisha, it has a unit. Molar, molar cancelled. It is per second. First order kinetics, unit is per second. K units are per second. We are going to discuss in detail. So now you have the K value. Now, can you answer this question now? This one. Plug in here. K is this 0.01, 0.30. So answer is 3.0 times 10 raised to the minus 3. Is this clear to everyone? In this question, so many questions are included. First, you get the rate law. See what you were doing. First, you started with assumption as x and y, and you worked out by using these 3 experiments. You worked out the rate law. You worked out the value of x and y. This was 0 and this is 1. Now you know the rate law. Then you calculate the value of k. So by using experiment 1, 2, 3, any one of them, k is going to be same. K is constant for all 3 experiments. To get the value of k. Once you have the value of k, then you can write down the rate law like this. Plug in k, plug in this concentration, to know the initial rate to fill this blank. So this is a detailed question, right? First, rate law. So you can break this question as free response. Like if this question is in free response, how this question will come? They will give you this data and they will ask you first part, what is the rate law? Second part, calculate the value of k, the rate constant k, with units. Answer with units. Unit is very important for k. Third, calculate the initial rate for the experiment 4. Then in that case, you have to show all the work, the one which we are doing here. So this can be a free response question. Okay, ready for this? No help from my side, children. Try it. So you see, these are the reactants, all 3. So rate law, assume the rate law. A raised to power x, B raised to power y, C raised to power z. You can say that, how did you come to know that all of them are reactant? Because they have given the initial concentrations. Initially, when the time is 0, you have only reactants, no product, right? So at time 0, all 3 are present. So that's why they are reactants. They are the part of my rate law. Work out the answer. You can mark it as experiment 1, 2, 3, 4, 5. Okay, x is 1. For knowing x, compare 2 and 3. See, cancelled. This is 2 times, and this is, I think, is 2 times. So you're right, it is 1. X is 1. Okay, now to know y, you're going to take 3 and 5. Am I right? Oh no, you cannot. So in that case, this is also cancelled. No, yes. Okay, good. We can take. Now this is halved, zero point 0.4 to zero point 0.2. And is there any change? No. Yes, y is 0. Perfect. Through 0. No change. See, the rate is same. To know the z, which two experiments, children? A and B should not be changing. I think these two, 0.2, 0.1. Is it exactly half or divided by 4? I think this is divided by 4. You divide it by 4, right? Means when this is halved, the rate has decreased by 1/4. So order is 2. 1 by 2 raised to power z is 1 over 4, which can be written as 1 over 2 raised to power 2. Z is 2. And that's why I think Atharva, Rahul, everybody was saying answer is E. Good. Very fast and very good. Okay, so I'm going to end the class. We have few more questions. We'll do it in the next class. If you have any questions, you can stay back.